All right, the saturated steam tables and the superheated steam tables. Properties of saturated water and steam. These happen to be, I think they're ABB, but I don't recall. Ask me steam tables. First table we come to. I know it looks daunting, but it's really very simple. You're going to see all of these columns. And if you'll note, there are going to be 3 for specific volume, 3 for enthalpy, 3 for entropy, 1 for pressure over here, 1 for pressure over here, and that's just for ease of use. So these are the same pressures. And then over here you'll see temperature. All right? That's 12 different columns right there. So if you'll look, I've got a temperature column. I've got a pressure column. I've got a V sub F column, a V sub FG, V sub G. Then it goes H sub F, H sub FG, H sub G. Then it's S sub F, S sub FG, S sub G. And these are separate columns coming on down with data. So I look up a certain pressure. If I look up atmospheric pressure in this book, I want to know if I had water existing at atmospheric pressure, what's its saturation temperature? At what temperature will it boil? And the first table here, these right here are called the temperature tables. They're pretty useful. It's the same data that's in the pressure tables in the back. They're just broken down into smaller increments. So I come down here and I'm looking at temperatures right here. And I see 173 degrees and I'm looking at pressure. That's 7 pounds absolute. Well, that's not going to work. That's a vacuum. I'm looking for an atmospheric pressure of 14.7. And I continue to come down and, oh, look, at 14.709, I see that the saturation temperature, the temperature which I would have that 1 pound mass of water would be completely saturated with energy, is 212 degrees. If I wanted to know the volume that 1 pound mass would occupy, I go to this column, the V sub F column, and I see that it will occupy 0.016. You got to know the units. This is cubic feet per pound mass for specific volume. For enthalpy, it's BTUs per pound mass, because it's specific enthalpy, specific volume. Specific entropy, BTUs per pound mass, degrees Rankine. Not as useful as the other two to us, but later on we'll find out ways to use that. So all you do is we found out that the temperature was 212 degrees, the pressure was 14.709 key, PSIA, and I can go across and figure out all of the properties of that water or steam at that point. So if I want to know what the specific volume is, I can look it up, V sub F. Remember, that is the properties right there, the volume that saturated water would contain at atmospheric temperature and pressure. I could look up V sub G, the volume that the steam would have. And I know that it would expanded massively as it turned from water to steam. So I would expect V sub G to be much greater than V sub F. And the difference between the two is nothing more than V sub FG. The same is true with enthalpy. I could look up the enthalpy at H sub F. I could then turn it to a steam and see what the enthalpy is once it's a saturated vapor. And the difference between the two, how much energy it took to turn a saturated liquid to a saturated vapor, is H sub Fg. And the same is true with entropy. This would be the entropy of the saturated liquid, the entropy of the saturated vapor, and the difference in entropy between the two, essentially the length of the line. Very important. If you're looking at your lesson plan, here's what's included in the steam tables. It's exactly what we just said. Also on that page, if I'm not at an F or a G point and I'm somewhere in the vapor dome, we know we have to solve for it. I can't look it up. And the equations are sitting right there for you. Anywhere along the point of this line right here, anywhere along it, as long as I can figure out the quality at that point, I can solve for it. H sub x, wherever I am along the line is x, is going to be equal to, well, at least H sub f plus what percentage across this line has it traveled? How much vapor is there versus water? Well, that's quality times the entire length of the line. And we can use this equation as seen for specific volume or entropy. There's a note down here on the bottom. H sub Fg represents the specific enthalpy to turn 1 pound mass of water to 1 pound mass of steam at the corresponding saturation pressure. And it probably should say to turn 1 pound mass of saturated water to 1 pound mass of saturated steam or dry steam. So you know that that means going from the F point to the G point.